times now, you are in a calculus class that also does a lot of physics, especially calculus BC friends. So let's look at this real quick. You've got, what function is that? What graph is that? Let's just like talk through your moves here. What kind of graph is this? This is the velocity graph, right? Mm-hmm. All right, so part A, you're asked to find the acceleration of the particle at time t equals 3. What are we going to do? Slope, you're going to find the derivative because acceleration is the derivative of the velocity. In part B, you have to decide if the speed of the particle is increasing or decreasing at time t equals 2. The work that you're going to do there?
Compare
You need two things. You need velocity and you need acceleration at time t equals 2. And if both of those have the same sign, then your conclusion is speed is increasing. If they have different signs, speed is decreasing. Good. Part C, find the total distance traveled by the particle on the interval 0 to 3. Total distance traveled. Total distance traveled. Let's get some hands on this. How do you find total distance traveled? I see Stephen, I see David, I see Carmen and Lewis and Celeste. Celeste, you weren't here. How do you find total distance traveled?
The absolute value of
the function, which is v of t, but there's more than that. If you're going to get total distance traveled, Lewis, what are we going to do? The definite integral from where to where?
0 to 3.
From 0 to 3, and we're integrating with respect to t. So you could say that it's the definite integral of the absolute value of the velocity, or another way to say this, absolute value of velocity is speed. Speed. All right, D, find the total distance traveled by the particle during the third second. During the third second. This is one that everybody always messes up. And I think it's not quite understanding time. When does the first second start? If we're measuring time, the first second starts at 0 and ends at
2. Wait.
Okay. The first second starts at 0 and ends at 1. So the third second starts at
2.
And ends at 3. Right, so when we say the third second, we're going from 2 to 3. And I want to make sure, because this whole idea with time messes up people's brains all the time. All right, E, determine the position of the particle. Not displacement, not total distance, now position. We're going to talk more about that in a little bit. Okay, part F, shut up. Okay, part F. I missed you, shut up. Okay, part F, using the midpoint method with 4 rectangles of equal width, estimate the position of the particle at time t equals 2. Clearly a Riemann sum. We're going to have conversations this morning about what do you do to find position. G, set up but do not evaluate an integral equation that can be used to determine the position of the particle at any time t. Again, position. H, for that time interval, at what time t is the particle farthest to the right? I would really circle that part there. Farthest to the right. I'm hoping that that's triggering some thoughts in the brain right now for the friends. Farthest to the right. There's something really specific we need to be thinking about here. Oh. If I am farthest to the right, that means something. There's an adjective that I'm hoping that we're thinking about right now. This is an absolute maximum kind of question. Right, farthest to the right means my position is most positive. Like I've gone as far as I can to the right. At what time is that going to happen, if anything? That's going to be the one that's going to take some time. All right, so with all that said, let's engage in some calculus fiction. I need you to understand deeply, Aaron, that this is calculus fiction. Okay, because it is. Aaron, can you read the introduction here for the calculus fiction?
To encourage,
it's on your...
I know, but I need to
Okay, it's on page 4.
To encourage more participation among any student, among my students, I have decided to offer the following incentive program. Whenever a student correctly answers the question, they receive 75 cents towards their college books next year. Using this information, consider the following situations.
Okay, this is fiction. I do not have 75 cents every single time you guys answer a question correctly. Okay, because I'm broke, I'm poor. Okay, you have got like 2 minutes to go through these 4 scenarios. There is no calculus being done here. This is calculus fiction, but it lays the foundation for all the work we're going to do. We'll talk in 2 minutes. If anybody needs a calculator, yes, you can use a calculator, but it's 75 cents, people.
The other question.
My corrections are
Thank you. Did you give me the original design?
it's stable.
My
correction.
Yep, thank you.
Do I need this? This mid?
I just multiplied 25.
Oh, I emailed it to you, right?
I don't know why the one,
Bad today. I am right.
Or you're doing it like.
Okay. These are meant to be wicked easy.
She was volume.
If she left it was Portuguese,
What is it?
What? 975?
okay, so he was on the
All right, friends. The names might be different from what I'm reading here. Fabricio answers 8 questions today. He will have accumulated how much money, Andrew? $6. All right, next one. We've got Victoria enters the class with $3.50 in her wallet. She answers 6 questions correctly today. She leaves the room with how much money, Palamon?
8.
We're on number 2. She comes in with $3.50 in her wallet. She answers 6 questions correctly. How much does she leave the room with? She leaves with $8. All right, situation 3. Jose ends the class with $9.50 in his wallet. Assuming he correctly answered 7 questions, how much did he have at the start? Carmen, how much? $4.25. And then finally, we've got Cynthia. Cynthia entered the class with $4.25 in her wallet. She left with $14 in her wallet. How many questions did she answer correctly, everybody?
13.
13 questions. We get this under control? And you might be thinking, what on earth does this have to do with calculus? You didn't find a derivative ever. You didn't integrate anything ever. What you did do, though, all of these problems have this form. The final amount,
I don't know what form, but I just have money.
right, however much you have at the end of the class period, is going to be determined by taking your initial amount. You might want to get this written down.
Oh.
Okay? The final amount that you have in your wallet, in your purse, is equal to the initial amount plus what? The final amount that you walk out with is equal to the initial amount plus
0.75.
Change.
plus 0.75
Times the question.
times like number of questions, right? Alright. And honestly, like I think honestly, like not trying to put anybody down, if we gave these questions to like a third grader or a fourth grader, these should be fair questions for everybody. Right? Like nice, they can understand this, they can see it. I'll tell you right now, this is the fundamental theorem of calculus. Almost. I'm not saying go home tonight and teach third and fourth graders the fundamental theorem of calculus. But if that makes sense to you, so will the fundamental theorem of calculus. It's no harder. So let me tell you what the fundamental theorem of calculus is and we'll tear this apart. So according to your textbook, you know, like if you had one, here's what the fundamental theorem of calculus says. If f is differentiable, differentiable means what? It's been a while. Continuous and derivative exists. So this is true for differentiable functions. Continuous and derivative exists on the interval AB. So it doesn't have to be true everywhere, but it has to be true on this particular interval. Then the fundamental theorem of calculus says that f of b equals f of a plus the integral from a to b of f prime of x dx. This is the fundamental theorem of calculus. That it is exactly this. There is no difference between that and this.
Oh, there's a lot.
There's no difference. On a high level, there's no difference. F prime, you guys know what this is. F prime represents the derivative. It represents a rate. This guy here is the rate of change of f of x. When I integrate, so another way to say rate of change, it's telling you how fast the function changes at any particular time. Everybody okay with this? Derivative is a rate. It's how fast. When I integrate a rate function, I switch from how fast the function changes to total amount of change, or how much the function changes. So how much function changes, now we've got to be specific here. How much the function changes from where to where?
A to B.
From A to B. The integral of the derivative is just telling you how much your function changed. That's it. How much did it change? Well, f of A is your starting point.
Oh, I got it.
Right? Starting point, or maybe you want to call it the initial value. F of B. It's your final value. It's your ending point. So what the fundamental theorem of calculus says is that for a differentiable function on the interval AB, the value of that function at the end is equal to that value of the function at the beginning plus how much the function changed on that interval. I'm going to say that again. The fundamental theorem of calculus says that for a differentiable function on a closed interval, the value of the function at the end is equal to the value of the function at the beginning plus the total change of the function over the interval. Everybody okay? All right, say that with me just one or two more times. Fundamental theorem of calculus says,
The fundamental theorem of calculus says,
for a differentiable function on a closed interval,
for a differentiable function on a closed interval,
the value of the function at the end
the value of the function at the end
is equal to the value of the function at the beginning
is equal to the value of the function at the beginning,
plus the total change of the function over the interval.
plus the total change of the function over the interval.
Okay, let's make it a little bit shorter. The fundamental theorem of calculus says
The fundamental theorem of calculus says,
the final value
the final value
equals the initial value
equals the initial value
plus the total change.
plus the total change.
Okay, one more time. Fundamental theorem of calculus says
The fundamental theorem of calculus
the
says,
final value
the final value
equals the initial value
equals the initial value
plus the total change.
plus the total change.
Okay, tell somebody near you in a really strange, awkward voice. Go.
The final value is the initial value plus the total change over the
Okay. Fundamental theorem of calculus just says final value
Until the end.
equals initial value plus the total change. It's just like
Now I know how to
this.
get time to
Okay. Everybody okay?
I'm like them.
Okay. Before we get into any of the problems, what questions might be out there about fundamental theorem of calculus? I'll take anything from anybody. Lewis.
Can you, like, I don't know, could you think the derivative, and then also the, like, backward from the derivative?
The backwards from the derivative, like the integral?
Yeah, so
Yeah.
is that like just F or what?
In a way, yes. The final value of the function is equal to the initial value of the function plus the total. Definite integral always means total. Derivative always means change, so I want to get both words there. It's the total change of the function on that interval. Other questions on the fundamental theorem of calculus? Everybody's good? All right, there will be some times where you might encounter the fundamental theorem of calculus this way written in a textbook. And I'm curious if that's any different or if it's the same.
No difference.
Is that a different version of the fundamental theorem of calculus or is it the same?
Same.
How many guys would say it's the same? And you see it's the same. Meyer, why do you see it being the same? Right, all we did is we said, okay, let's move the f of a over here. Stephen, and all of your Googling, you know where we're moving to, don't you? Just fake it, yes. Okay. Well, what's this part over here again? What's it telling you?
The
Total change.
It's the total change. How do you find the change in anything? You look at where did you end, you look at where you started, and you find the difference between the two of them. Everybody good? This fundamental theorem of calculus, this guy is going to show up more than anything else we're going to study probably in the entire course. And I am not going to say use the fundamental theorem of calculus. You're going to have to know that it's a fundamental theorem of calculus question. Alright, so why don't you guys take out your calculator. You won't need it for this first one, but you will need it in just a little bit. Alright, I'm going to get out of the way. I want to give you guys a chance to see what you can do with this first one. Probably never ever use the phrase fundamental theorem of calculus in a word problem.
Why would you?
The figure to the left shows the graph of f prime. That might be important. F prime is the derivative. F of 0 is equal to 1. Find the values of f of 4 and f of negative 1. If I'm going to find f of 4, I need to know more stuff about the function. Clearly, because we're studying fundamental theorem of calculus, this has to be a fundamental theorem of calculus question. How am I going to apply the fundamental theorem of calculus to get f of 4? Let's get some hands on this. What could you do? What you want is f of 4. The fundamental theorem of calculus says the value of the function at the end is equal to the value of the function at the beginning plus the total change. So they gave me one thing. They told me f of 0 is 1, right? So f of 4 is equal to f of 0. Don't stop there though. Plus the integral from 0 to 4. This is the value of the function at the end. This is the value of the function at the beginning, plus that total change. Well, this is the total. The change is represented by f prime of x dx. F of 4 is equal to f of 0 plus the integral from 0 to 4 f prime of x dx. If you've got that written down, first point earned. How many of you guys had that as your setup? 1, maybe 2, maybe 3? Okay, well, what do we know? Do we know f of 0?
Yes.
Yep. Plus, do we know the integral from 0 to 4 of f prime of x dx? Or do we have a way to get that information? We have a way. David, what's that way?
Using graph.
You're going to use the graph. Tell me how you're going to use the graph. Be specific. This guy here, this notation is telling you to do something really specific with the graph.
Oh, you go the area bounded by that.
I want the area. I want the area bounded by the graph of f prime. It's okay to look at the graph of f prime. From 0, here's 0, to 4, here's 4. I need this area, that area, that area. So the area from 0 to 1, what is that? It's going to be a half. The base is 1 and the height is 2. The area of the circle, what is that? That's pi times the radius squared, cut it in half. The area of this last one is 1/2 times 1 times 1. Okay, and the mistake that we need to make sure that we avoid? What's that mistake that somebody's going to make? Not anybody in this class. Aaron, what's the mistake?
The area of the semicircle is negative.
The area of the semicircle has to be negative. It has no choice. That has to be counted as negative. This guy has to be counted as positive. I'd say at that point, second point earned. Simplify at your peril. 1 plus, what is that? 1 there, minus pi over 2, plus a half. Maybe I'm going to write this on a test as 5 minus pi over 2. 1 plus 1 is 2. 2.5 is 5/2. Minus pi over 2, 5 minus pi over 2. I know I went fast on the simplifying. Free response, you can stop here. All that you can do is throw away a point by simplifying. But this could be where it shows up in the multiple choice. Everybody good? Try the next one. No, not as in number 2, as in the next part of number 1. F of negative 1. So just did a quick lap, and some people are saying f of negative 1 equals f of 0 plus the integral from 0 to negative 1 of f prime of x dx. Other people are saying that f of 0 equals f of negative 1 plus the integral from negative 1 to 0 of f prime of x dx. How many guys see it as the first way? How many guys are seeing it as the second way? Okay, so everybody's seeing it as the second way? Okay, go for it. We'll talk in a bit. I'm going to do it the first way. F of negative 1 is what I want. F of 0 is 1. Gosh, how would I ever find the integral from 0 to negative 1 if I'm starting at 0 and going left of negative 1? That's the same thing as switching my limits of integration but subtracting. Now the area from negative 1 to 0, this should be 1 minus a half times 1 times 2. I think that's 0. For the folks that are doing it this way, f of 0 is the thing that you know, so 1 equals f of negative 1, what I don't know, plus the area from negative 1 to 0, that's 1. And so we're going to get that 0 is equal to f of negative 1. Good news. Both ways work. Whether you want to do, whether you say f of negative 1 equals f of 0 plus the integral from 0 to negative 1, which means you're going backwards, or you're going in the forward direction, it's okay. Everybody good? Giselle, you feeling good about this? Okay. Andrew, you good on this? All right, so you guys can do it number 2.
Oh wait, no.
I pause for
I
a
was
second.
talking
I'm
to
like,
myself.
you're not talking to me.
No, I was talking to myself.
Focus. No.
I was like,
No, I was like doing something.
I've never killed a child in class. Steven, if I just say stop filming at some point, you're gonna stop filming, right?
Yeah. No one believes.
Nobody needs any video proof.
oh my god, where's me?
Alright, consider a function f of x such that f of 1 equals negative 4, f prime of x equals x cosine of x. Find the value of f of pi. LA, what are your thoughts? How are we going to find f of pi?
F pi equals F of 1.
F of pi equals f of 1.
Yeah, that's where I got lost.
Okay, that's where you got lost. Okay. Let somebody help her out. We've got f of pi, we've got f of 1. Lewis, what are you going to do from here?
Plus the definite.
Plus your definite integral
From 1 to pi.
from 1 to pi
F prime of x.
of this x times cosine of x dx. LA, f of pi is your final value. F of 1 is the initial value. And remember, this guy over here is f prime is your change. It's telling you how fast the function changes. So f of pi equals f of 1 plus the integral from 1 to pi. X cosine of x, hopefully everybody's got this typed into their calculator. We're getting a number answer. Myra, what do you get for your decimal, your answer?
Negative 2.382.
Negative 2.382. Can I get some confirmation? Negative 2.382. Everybody good? All right, go get me f of negative pi, please. Usually with the fundamental theorem of calculus, they're going to give you 2 of the 3 pieces of information. The final value, the initial value, or the total change. Yes, sir. Invalid implied multiplier. Okay. Plus the integral from 1 to pi x times this. Wait a minute. Okay, Lewis and I are getting negative 6.382. Negative 6.382? So I bet when you told me negative 2.382, was that just the value for the definite integral?
Oh yes.
Ah, okay. Thanks. Negative 6.382. Okay, f of negative pi. Let's get some hands on this. What's your setup? I don't care about the number, I care about the setup. How are you going to get f of negative pi? Just Lewis? Oh, that's a little painful. Okay, Lewis, what you got?
F of negative pi equals f of 1.
Okay, and you're using f of 1 because you know the value of f of 1, right? Okay. And then what?
Plus the definite integral from negative pi to 1.
Okay, now here's where you got to be careful. F of negative pi is what we're considering the final value. F of 1 is what you're considering the initial value. So final equals the initial plus you have to integrate from initial to final.
Negative.
Nope. Oh, negative pi, yes.
He said no. I was like,
Sorry.
no, you're.
Don't change the sign here because the integral takes into account the fact that you're going to have to do a subtraction instead. Fundamental theorem, f of b equals f of a plus the integral from a to b. This is a, that's b, this is a, that's b. That's a way to get the answer, and I think if you get the numerical answer right, Myra, what are we getting this time? Samesies, negative 6.382. That's one way we could use the fundamental theorem of calculus to get the right answer. I want you to have a strategy conversation with somebody near you. Give me 2 other ways you could use the fundamental theorem of calculus to find f of negative pi. Get creative here. How else could you use the fundamental theorem of calculus?
Yes. So what?
What legal things could you do? I know it's a Monday and so are you. How else could you use the fundamental theorem of calculus? Right now I'm thinking about what are the ways I might show this on a multiple choice test that hides it from you. The goal is to find f of negative pi.
Oh, yeah.
You could write it.
They're starting with
You could write it. Anybody with subtraction symbol? Remember when we switched to use subtraction symbol?
Alright, let's get some hands on this. What ideas are out there for how you could use the fundamental theorem of calculus? Lewis, you're frozen for a little bit. What else could you do with the fundamental theorem of calculus here? Okay, well, I guess we'll just wait and see what happens on the next test.
Wait, I don't know if he's right.
But that's what's going to happen. I would rather you take a risk and be wrong than sit there and stare at me.
I was considering.
Yeah, what were you
asked us
considering?
A previous question about how you wrote it
Okay.
when you flipped the integral, but you just changed the symbol of it to a negative sign.
Okay, so tell me what that's going to look like here.
It would be f of negative pi would equal f of 1 minus the definite integral of from negative pi to 1,
Negative pi to 1.
and then x
Then
times
the x
cos x
cosine of x
times
dx.
dx. Yeah.
Love it. That works. Other ways. David.
F of negative pi minus f of 1
F of negative pi minus f of 1.
equals the definite integral of 1 to negative pi.
And then x cosine of x dx. Love it. These are all legitimate ways. Lewis, you get something new for me?
f of 1 equals f of negative pi
F of 1 equals f of negative pi plus
definite integral from negative pi to
from negative pi to 1 of x cosine of x dx. I hope you guys are getting this down. That's another great way to do this. How about this? F of negative pi equals f of pi plus the integral from pi to negative pi x cosine of x dx. Does that work?
That's what I said. I said we can use
Does that work?
Yes.
Aaron, why does that work?
Because you still have the final amount on the left side.
Right? The value that I'm trying to figure out is f of negative pi.
And you have your initial amount, which is f of pi, plus your rate of change.
Right? Because of the work that I did before, we know what f of pi is. I could use that as my starting value. So f of negative pi equals f of pi plus the integral from pi to negative pi of x cosine of x dx. Or if you wanted to, f of pi equals f of negative pi plus the integral from negative pi to pi. Blah, blah, blah. Okay? I just want to think about, like, you've got a lot of flexibility. You've got a lot of utility here with the fundamental theorem of calculus. Okay? All right, last one, and then you guys are going to get some good practice time. All right, so here we go. A particle is moving along the x-axis with velocity modeled by a differentiable function v. Selected values of v are given in the table above. The initial position of the particle is given by x of 0 equals negative 4 meters. Use a trapezoidal approximation with 5 subintervals to estimate the position of the particle at time t equals 32. Show the work that leads to your answer.
Let's do this.
Calculus, a fundamental theorem of calculus question. The fundamental theorem of calculus says f of b equals f of a plus the integral from a to b of f prime of x dx. Final value, initial value, total change in the value over that interval. They told me x of 0 equals -4. Is everybody okay that that's going to be our initial value? Okay. All right, what I'm looking for is what's the position of the particle at time t equals 32? Final value?
32.
So that means position at time 32 is equal to position at time 0 plus, if I'm just following the fundamental theorem of calculus, position at 32 is equal to position at time 0 plus
0
integral from 0
to 32.
to 32 of what?
DFT.
Now, at first, if you're, and this like often happens in an AB class, students are like x of 32 equals x of 0 plus the integral from 0 to 32 of x prime, because that's how the fundamental theorem of calculus works. But we know if x represents position,
The derivative.
what's the derivative of position?
The velocity.
Velocity.
It's the velocity. So what I'm really asking you to do here is you're going to take your -4 plus the integral from 0 to 32 of v of t dt. What I want is area under a curve. Another way to express this integral from 0 to 32 v of t dt, if I wanted one word to tell me what this is. The integral from 0 to 32 of velocity, one word. One physics word. Displacement. Now, this has to be displacement. Specifically, it's the displacement from t equals 0 to t equals 32. Right? Initial position, add that onto your displacement, your change in position has to give you final position. And quite honestly, I'm not even interested in what the number is. So let's just go through and do the setup and call it a day. Okay. So we've got -4 plus, what method did they say here? Trapezoids. I need 5 of them. And I'm going from 0 to 32. Somebody give me the setup for the first trapezoid. And then you're frozen out for a little bit. David, give me the first one, then you're frozen.
It's gonna be with the 5, doing height 5 time.
Okay, so we're looking over here.
Yeah.
Okay, your trapezoid starts with a half.
For first base -5
First base is -5.
plus -1.
Plus -1, base 1 plus base 2 times the height. The height is that perpendicular distance between the two, which is 5. David, you're frozen, but thank you very much for your service to the class. All right, somebody else, second trapezoid. What's your setup in the second one, Aaron?
Well, the first part was still the negative. Well, you don't have the -4, which the 1/2 first.
Yeah.
And then you have, wait, is that, what, I have it already.
Yeah, you got it in front of you.
6 plus 10.
Whoa.
You skipped an interval.
Oh, I
You
did. I skipped the interval.
Right, you've got overlapping
Right.
intervals here.
-1 plus 6
You've got -1 plus 6.
times, is that 8?
All right, you're frozen. Thank you very much. And Carmen, give me the third trapezoid.
Plus 1/2.
1/2.
Yeah.
Stop whispering to her. She's wicked smart.
10 plus 6.
10 plus 6, so I'm going to write it as 6 plus 10.
No.
Okay, I think for the folks that are struggling with this, it might not be a bad idea to plot the points. Like 13 comma 6 would be over here. 20 comma 10 is over here. Your trapezoid looks like that. You have a height of 6, you have a height of 10, or base of 6 and a base of 10. Perpendicular distance between those two is 7. So 1/2 6 plus 10 times 7 1/2, the next one should be 10 plus 2 times 2 plus 1/2, I'll go on to the next one. 2 plus -3 times 10. Whatever that works out to be, I have no interest. But according to my calculations from earlier, this might be, no, it's not going to be that.
11.
11? Maybe, we'll see. Alright, I'm interested to see what you guys can do with this last part.
The answer possibly 11.
I'm going to work this out while you guys tackle that last part.
Ish.
It's -6, it's -30. -15, that's 5, that's 40, that's 20. That's 16, that's 8, that's 56.
This is probably
That's 12, that's 24, that's 12. That's -1, that's -10, that's -5. -19, -24. 64.
Oh, 11 was close.
Wait.
Oh yeah, 11, at least it's a number.
Yeah, close to 64.
Where'd I get 56? When I did 1/2 of 6 plus 10 times 7?
Oh.
Determine the value of the integral from 13 to 32 of v prime of t dt. You've got some smart cookies in the cookie jar.
What'd you get? Yeah, because you subtract this and roll it over. Yeah. Subtract this part and roll it over.
Okay.
So, in order to
You
find
good? Keep going.
the
Keep working.
inputs,
Yeah,
you
bro.
have to do
Alright, so -3, v of 13 is 6.
You did all good.
Alright, if all goes well, I think the right answer is -9.
See,
Yeah.
Okay, I'm curious, how many of you guys set it up this way? You did like the fundamental theorem of calculus in this order? V of 32 plus V of 13 plus the integral of 13 to 32? That was most folks? Did anybody think about doing it that way?
I did it.
I was thinking about it.
But I did it on the table.
Okay, right, V prime is how fast velocity changes. So the integral has to be how much the velocity changes from 13 to 32. Find the velocity at 32, find the velocity at 13, subtract those two to get -9. In terms of the meaning, what I'd want to see is it's the total what?
the total change in. No, it's not.
V of t is your velocity. V prime is the rate of change. It's how fast the velocity changes. So this is acceleration, but when you integrate, what you get is how much the velocity changes. So I would say this is the total change in velocity. Now be careful. From t equals 13 to t equals 32. And what are we measuring in here?
Meters
Not meters.
No, meters per second.
per second.
Right, the units of meters don't make sense here. You're measuring velocity minus velocity. So this is meters per second. Meters per second, so that -9 has to represent meters per second. Now, there's only one thing that's wrong with the write-up, and sometimes the College Board is really picky about this, and sometimes they're not so picky about this. The word change is often considered a bad word. It's almost like the word it, because the word change isn't specific enough. There's a more specific word we should be thinking about here.
Feet.
You're going to get rid of the word change and put in feet. I didn't see that coming. When we talk about change, there's two kinds of change that we normally think about. There's an increase and there's a decrease. The most specific word to use here,
Decrease.
look at the number,
Decrease.
decrease. So rather than total change, I'd rather see total decrease in velocity. So you are going slower than you were before. Okay? We've only got a couple minutes left. I think it would be a really good idea to get started on that journal entry. The journal entry is the homework. The first couple of parts should be way fast because it's just, you know what to do.